Good morning, everybody. Welcome to this session of PLSQL. Now that we have completed SQL, it's time for us to look into what this PLSQL is all about. So today we'll have an introduction to PLSQL, and from the next session, we'll actually start with PLSQL. Now, while we are using this term PLSQL, so we need to have a very good understanding what is there in this particular course of PLSQL, what this PLSQL is all about, and how does it really work. So today's session is all about introduction to this particular language called as PLSQL. So let's begin with our introduction. So what is the objective of today's session? Today we plan to understand why do you need to go in for this PLSQL. Rather, even before that, I'll discuss what exactly is PLSQL. I hope I'm audible.
Yes,
Okay. We will also check into what are the benefits of PLSQL. We identify different types of PLSQL blocks which are there. Although we are not going to go into details, we'll just identify what are those blocks. Okay, and in tomorrow's session, we'll actually start exploring each of those blocks. But today we'll just identify what are the different types of PLSQL blocks that we come across. How do you send the output messages in PLSQL? What are the different ways? And the latest version that we are talking about is 14.0. So that's the version that we are going to use. It was released just recently on in the month of April 2020. So there are some new features that it has introduced. So we in the course we'll be exploring the new features, but just for your information, the version of PLSQL that we will be working on will be 14.0, released in April 2020. So that's the latest version of PLSQL that we'll be working on. So let's begin our discussion with this very interesting language called as PLSQL. So what is PLSQL? What does it stand for? The PL stands for procedural language. So it's a procedural language extension to SQL. Now, when I use the word extension to SQL, that is what we need to understand. If you look at the diagram that has been given over here, we have the SQL, the traditional SQL that we have been knowing. So SQL instructions that we have learned or you already know. Plus, it gives you the power of your procedural language construct like if else, the loops, and everything. So your procedural language constructs, okay, plus the SQL creates a PLSQL for us. So to put in simple words, PLSQL is SQL plus the procedural language constraint, or the procedural language constraint along with SQL creates a PLSQL. So that is what PLSQL is all about. It's a Oracle Corporation Standard Data Access Language for relational database. So this is not something like SQL, which is acceptable across all the databases. This is specifically for Oracle. It provides seamless integration of procedural construct with SQL. So all the procedural language construct that you have learned in C and other things, right from functions to if-else construct to looping constructs and everything that you have learned, and even the advanced construct like what you learn in object-oriented language like exception handling and everything, all the procedural language construct plus the SQL as a language creates a new language that is PLSQL. While SQL was a standard language to access any relational database, this power of procedural language has now been provided by Oracle to SQL to create a new language that is procedural language extension to SQL, PL SQL. A lot of time people say it's programming language for SQL. That's okay, but actually it is procedural language extension to SQL. Now, to begin with, you'll realize as we go ahead learning this particular language, it is just like any new language that you learn. It will have its own syntax, okay, and the syntax will determine how the statements really work. So, in every language, what do you start learning with, or what have you learned while you started learning languages previously? We started with data types, then we learned the syntax, the simple programming constructs like if-else, the loops, and other things. So, we will follow the same kind of sequence over here as well. Here also you'll come across the data types, you will come across the looping constructs, you will come across all the programming constructs that you have already come across in any other traditional programming language. So it's just like any other programming language, this will have its own syntax, own rules, and believe me, if you have exposure to some programming language, you will find it quite easy because you know what to expect out of this. I am definitely sure that none of you is learning programming for the first time. You already have exposure to some other programming language. So this becomes an easy experience for us. So what we need to look into here is just the new constructs that have now been provided, or not even the new construct, new syntax for this existing constructs that you are already aware of. So this course can run a bit fast because I don't really have to explain you what's the purpose of if else, what's the purpose of loop. I don't have to spend my time doing this. So normally when we take up this particular course of PLSQL, this gets covered up quite quickly, because while you're learning programming language, let's say you're learning Python or you're learning C, you have to spend time understanding the very reason why that construct has been introduced. Now here, I can directly jump on how to use it because you're already aware of some programming language. If uh, and that's what I make an assumption that all of you are exposed to some programming language. If it is not, you will have to bring it to my notice so that I can discuss a brief about why that construct is required. So it's just like any other programming language. It will have its own syntax, the own rules, and that determines how programming statements work together. So if you have a looping construct, those statements will repeat it. If you had if-else construct, either of the statements will get executed. Same, all the same. Even the syntax appears very similar to all your traditional programming language. It's not a standalone programming language. So it's not something like, oh, I'll take PLSQL and I'll run where there is no Oracle database installed. No, no, no. It's not a standalone programming language. Most of your languages are standalone. They can run independently. This is not a standalone programming language. This has been precisely created to extend the power of SQL. So where your Oracle is installed, where SQL is running, only there we can have go ahead using this PLSQL. It's a part of Oracle RDBMS. So only where Oracle is being installed, there you can expect this language to work. It is not something which is standalone, which will run without Oracle being installed. That's something which will not happen. It provides a block structure for executable units of code. Block structure. We are aware of blocks. Remember, in C++, you could create or any programming language, we either create a nested block just by putting a curly braces. In Python, you can create a block just by indentation, correct? And you can give a name to a block by creating a function or a procedure in other languages and so on. So likewise over here also you'll have a lot of blocks. These blocks will actually contain the executable code. The code that we would like to execute will be actually included inside a block. So here we'll have units of code which are executable, which will be supplied to us in a block structure. So we need to understand what are the various block structures, what is the basic design of a block structure. So tomorrow's session will be entirely about those understanding those blocks. Or even today, I'll give a brief about what are blocks to expect in this particular course. So we're going to have a quick review of them. Maintenance of code is made easier with such well-defined structure. It's not like I'll go ahead writing the entire script of 1,000 lines. No, I'll break it down into various blocks. I'll give a meaningful name to that block. So I'll understand which part of my code is doing what kind of operation. Remember the concept of functions. So I'll divide my code into various blocks and I'll very clearly specify this block is doing this task. This block is doing this task. So maintenance of the code also becomes very easy because we have decomposed that big block into several small blocks. It provides all the procedural language construct like variables, constants, data types in addition to the data types that you have learned till now. So you'll have everything, variables, constants, data type. That's what we have in all the programming languages. It will have control structures such as conditional statements and loops, if else and loops, whatever you'd like to have, various steps to do. And it has a reusable programming units that are written once and executed many times. Something like your functions. Here we have something in addition to functions, but basic idea is the same thing. So we'll have something like functions, which are reusable program units. So you write it once, you can keep it in the library, and you can get it from the library. Like what we do in most of the languages, we import from the library and we start using it, isn't it? So here also we have an opportunity to create those database objects which are reusable, stored in the database, and in future, any application developer can use it. It's not like it's one-time use. Although I can create one-time use kind of constructs, but then what is recommended? If there exists a possibility that the same code will be required in future, why not store it somewhere? So there is a mechanism through which I store it in some kind of packages. Remember the term packages. We have come across this term packages so very often in Python, in Java, in C++, we had header files. So we create those header files, keep the related functions and everything together over there. Similarly, we'll have the concept of packages, which will help us group related kind of code blocks. And so I can just get that package and start using the functions and all the code blocks which are pre-written. So that will save my time. That will make my application more reliable. So there are several advantages of going ahead with PLSQL. What can you do with PLSQL? Okay, so with PLSQL, You can manipulate Oracle data. That's precisely the purpose for which PLSQL has been created. It can manipulate the flow control statement to process the data. Now, sometimes I have to carry out some operation repeatedly. Now, I don't have any such kind of feature provided in SQL to do that. So, if I want to do that, the control flow of your program can be more, script can be more properly controlled by using this language. It defines subprograms, procedures, functions. Subprograms, procedures, and functions. These are my reusable units. So I can create those reusable units and I can use it anytime in my program. And then it can trap runtime errors. So a very good support for exception handling has also been provided. So you can actually write quite a complex programs, applications. You can develop entire application using PLSQL. That's very much possible because whatever is required, all those support are actually being provided here. Also have this support for very powerful feature, that is exception handling. So your business logic and the handlers do not clutter the code. All of them are segregated. So what are you advantages that you have seen about this advanced feature of exceptions, where we don't have to really keep on watching what that function has returned, rather it will be automated. So those features, exception handlings, are also provided over here. It combines the data manipulation power of SQL with the data processing power of procedural languages. Now, for processing the data, as I told you earlier, we have to have something which will decide whether I should do this operation or that operation, whether I should do this 10 times, 100 times, and all those things. So that kind of procedural power is now provided to SQL. So what SQL lagged, that additional, those missing parts of SQL has now been provided by this PL SQL. It will provide you features like data encapsulation, exception handling, information handling, object-oriented programming. Everything that we have learned in all of the programming languages will now be supplied to us over here. It brings the state-of-art programming to Oracle server and toolsets, provides all procedural language constructs that are available in third generation language. So whatever you know about the constructs, right from selection constructs to looping construct to this exception handling construct, whatever, except for the fourth generation languages, third generation language, whatever features they provide, all those features are also supplied to us in by this PLSQL. Now, what's the need for going ahead with PLSQL? So a lot of Oracle applications are built using client server architecture. That means the client is running at a different place, and some part of the process is happening at a different place, and server is doing some kind of processing. And the data is actually there on the server, so multiple user can connect to that particular server and use the same data. So we normally have this client server architecture at enterprise level. Currently in our course, we are actually working on a single machine. That will not be the case at the enterprise level. There will be hundreds of users accessing the same data source, and there is where it's very important. It plays a very important role. The program that makes a request against the database resides on the client's machine. So the application is on the client machine that is constantly making a request to the server where the data resides. So data on the server is being processed by an application which is there on the client machine. Think about a Java application running on the client side, and that Java application making a request to a server every now and then. And the data is residing on the server. So for every small thing, it has to fetch the data from the server and then go ahead carrying out processing. That's the normal thing that now actually come across in application if it's a client server application. So the program that makes a request against the database resides on the client machine. So data is on the server and the program is on the client side. Program is on the client side. And that's constantly doing some kind of processing. And wherever data is required, it connects to the server, downloads that data, gets the data from the server, and then goes ahead with the processing. So here PLSQL can bring about a difference. PLSQL written, this program can be written C, Java, or PLSQL. So the client side program, till date we have written in Java and Java. C we haven't yet written, but I have promised in this course I will give a demonstration as to how we can go ahead creating an embedded C program which will connect to a database. But that it is written C, but Java is something that we normally do use. So the client side program is written in this, or today now with this new language, you can write this client side code in PLSQL as well. PLSQL is a part of Oracle RDMS and it resides in two environments, that is the client and the server side. This is something that Java or C will not provide you. That means this particular code will be stored as a part of my database object. It can be on the client side, it can be on the server side. You'll say, so how does it matter whether it's on the client side and server side? It does have a huge performance impact depending on how the PLSQL, where the PLSQL code resides and how it actually running. And that is what I'll discuss today in this particular session. What kind of impact does it have depending on where it has been stored? Have a look at this PLSQL runtime architecture. Okay. Now, if you have seen this architecture, now let's go ahead discussing it, because today we'll primarily understand how is this particular thing really working. So we have a database. Just understand we have a uh, database. So this is my database somewhere over here. The database is holding some kind of data which is there, which needs to be processed, which needs to be handled. So there is some data, and you have this PLSQL code block that is being currently executed. Now, any PLSQL code block that has to be executed has to be sent to something called as PLSQL engine. So and PLSQL is what? PLSQL is an extension to programming language, procedural language extension to SQL. So it will provide you features through which you can execute the SQL statements only. So we'll have the programming language constructs plus the SQL. Remember the first diagram that we took to understand what PLSQL is about. Don't forget about this diagram. So that summarizes the entire story for PLSQL. You have the procedural language constructs plus the SQL as a language creates a new language called as PLSQL. So that means whenever I write the PLSQL code block, this PLSQL code block will definitely contain several SQL statements. Listen, huh? The PLSQL code block will contain several SQL statements. But when you're trying to execute a PLSQL code block, that code block will definitely go to something called as PLSQL engine. I'll talk more about it as I go ahead. We'll go to something called as PLSQL engine. This PLSQL engine, when the code goes, the code consists of two parts. One is the procedural language constructs, and second is the SQL. The SQL part that is there in the procedural language construct will now be submitted to the SQL statement executor. So there will be something called as SQL statement executor that will take the responsibility of executing the SQL statements which are present inside my PLSQL statement. Or it may also happen your SQL statements internally calls certain things, and they are the PLSQL code blocks which are being executed. So if when it comes to an SQL that is there in PLSQL code block, that will go to the SQL statement executor. Within the SQL statement executor, if you are invoking any PLSQL statement, that will again go to the PLSQL or procedural statement executor. So what is happening? The PLSQL code block, all the procedural language constructs are executed something by procedural statement executor. The SQL statements which are there, that means the if else and the looping construct, they'll be executed by procedural statement executor, and the SQL part of it will be executed by the SQL statement executor. So there are two executors for us. One is the SQL statement executor, and other is the procedural statement executor. The SQL statement executor is now residing on the server side. It's residing on the server because the data is on the server. So it is residing on the server side. And the procedural language executor is residing, it can reside on the server, it can reside on the client, it can reside at either of the places. So that's not difficult, that's not a problem for us. But within your PLSQL, if there is any statement which is in SQL, that will be forwarded to the SQL statement executor which is there on the server. That server, in case if it triggers any PLSQL code, that will again come to the procedural language executor, and that will be executed and go there. So that's a brief idea how it is working. But let's go into understanding the things in detail. See, PLSQL code can reside on the client and the server, both the side. It is very easy to move the PLSQL modules between the server side and the client side application, because both of them understand wherever your database is there, the code can be there on the server side, code can be there on the client side. You don't have to put in any extra efforts while you move your code from the server to the client or the client to the server. So the code can seamlessly pass from the client to the server or from the server to the client if it has to be executed at either of the places. When the PLSQL engine is located on the server, uh, this PLSQL engine is located on the server, the whole PLSQL block is passed to the PLSQL engine on the Oracle server. What do they say? When the PLSQL engine is located on the server, the whole PLSQL block is passed to the PLSQL engine on the Oracle server. That means on the client side, you write some script. The correct PLSQL block is what you have written, and that has to be executed. So the entire block will be actually sent to the server, because server can also understand it. The entire block will be sent to the server. How it is sent, that also I'll discuss today. The entire block is sent to the server, and then server can process that entire block, which also contains some SQL statements. So idea is, if the SQL engine is residing on the server, Any PLSQL block that you like to execute, the entire PLSQL block will be sent to the Oracle server. That Oracle server will have this PLSQL engine, and then that PLSQL engine will interact with the database or the SQL statement executor and execute the statements and so on. But then the entire block can be sent to the Oracle server at one go. Entire block can be sent to the Oracle server at one go. When the PLSQL engine is located on the client side, so I said you have both the opportunities. You can keep it on the server side, you can keep it on the client side. Okay, as in its like Oracle development tools, the PLSQL process is done on the client side. Now this is interesting. The PLSQL process is done on the client side. That means your client side also will be in a position to run those procedural language construct. The server can also run the procedural language constructs. Both of them can run. All the SQL statements that are embedded in the PLSQL block is sent to the Oracle server for further processing. Means the procedural language construct will get executed on the client side, and where it has to interact with the data, those statements will be sent to the SQL statement executor that is residing, or SQL statement processor, SQL statement executor that is residing on the server. So two choice. Either the entire thing is kept on the server side and you write a code on your client side, and that entire PLSQL block is sent to the server where both the things are there. The the PLSQL engine along with the SQL statement executor, everything is there on the server side. So all the processing will happen on the server side. That's one choice that you have. The second opportunity that you have is the PLSQL engine is on the client side. Now, since the PLSQL engine is in the client side, while you're running the code, the procedural language constructs will now get executed on the client side itself, will get executed on the client side. And inside that, wherever your PLSQL code block is referring to the SQL statements, which requires some kind of processing, which requires interaction with the data, that code is sent to the server. The SQL statement executor or the SQL statement processor, which is there on the server, it will execute it and then it will send the data back. Now, what happens otherwise? If I'm not using PLSQL, what happens? How does PLSQL improve the performance while I'm working with this client server technology? When PLSQL block contains no SQL statements, that could also be the possibility. The entire block is executed on the client side. So it's not necessary that every PLSQL code block will have a SQL statement embedded inside it. If there are no SQL statements which are embedded inside it, if there are no SQL statements embedded inside it, and your PLSQL engine is on the client side, the entire code block will get executed on the client side itself. But wherever the SQL statement comes inside it, the client side will not execute that SQL statement. That will be sent to the server, and the server will have the SQL statement executor, and that will execute it. So there also exists a possibility that you are doing some stuff, and inside that particular operation, there are no SQL statements which are there. So the entire processing can happen on the client side. There is no need for you to request to the server to do some kind of processing. So you have your own advantages of storing the PL or keeping the PLSQL engine on the server side or on the client side. Now here we go. We have this PLSQL block. This PLSQL block, which contains PLSQL as well as the SQL, that is sent to the SQL engine. Now, when this PLSQL block processing starts, if it finds there are some procedural language constructs, though this is just a recap, those procedural language constructs are sent to the procedural statement executor, and that will take the responsibility of executing those statements. But within your PLSQL block, if there is any SQL statement that is sent to the Oracle server, okay, now point is this PLSQL engine can be present on the client or it could have been present on the server. In the last case, it was present on the server. This time it is present on the client side. So in that case, the SQL statements will be sent to the Oracle server. The Oracle server will have the SQL statement executor. But while these statements are executed, in case if it requires some, if it invokes some procedural construct, that will again come back to the PLSQL engine and that will go ahead doing those execution. Now, let me know, have you understood whatever we have discussed so far? Give a feedback, quick, or if there is a query, please ask before we go ahead. Okay. Now that we have discussed the basic thing about what this PLSQL is all about, it's time for us to go a bit ahead. Now, we'll talk about the various PLSQL development environments which are available, because we are developers, correct? So we are going to write those PLSQL blocks. We are not just going to execute those PLSQL blocks. So as a developer, we need to know how do I go ahead developing these PLSQL applications. Like entire applications can be developed. How we can go ahead writing these PLSQL blocks. Okay. The course setup provides the following tools for the PLSQL code. So in this course, there are various options which are available. Some of them we'll be using and some of them we will not be using. So let me just reveal to you what we'll be doing it. Now this entire SQL course, we took it on the command line interface, CLI, isn't it? Every day I used to write something, type something, enter and this and that. So we did the hard way out. But now we are so very familiar with this command line interface. And I'm sure by experimenting with those things, running those queries, you must have also been very familiar with the command line interface. Now it's quite a long time that we have been working on command line interface. Around 30 odd sessions we have worked on command line interface, especially while you are working with SQL. Now it's time to graduate. It's time to graduate and to use some additional development tools which are available. So one that we'll be using is an Oracle SQL developer. So this is the tool that, or ID you can say, that we'll be using in this course for PLSQL, and that's going to make us more productive, because I'll not be bothered with the small things about SQL. Now that we know SQL, so I'll presume that since we know it, we can directly start using it without bothering about how it was created and how it was stored. Those things we already know now. It's just like the data that is there in the SQL, and now is there, SQL can process the data that is there in the database. So we're directly going to start using this SQL to process the data that is stored in my database. But I'm not going to worry about small things like I want to see the table structure. So I no longer will type describe so and so. I want to see the records. I will no longer say select so and so something something. I'll not do that. Rather, we'll have a graphical user interface, and that is what this Oracle SQL developer will provide us. You have an opportunity to run your code through the SQL prompt as well. I told you, na, I come from uh, mm, the old school, and we are very familiar with the command line interface. So although I'm saying I'll use SQL developer, but time and again you find me going back to the command prompt, yeah, the command prompt, the SQL, the command line interface that SQL developer provides. So I'm not going to worry about using SQL developer for PLSQL. Am I audible?
So now
Uh,
you
no, sir. No, you're
Abhi,
audible.
before that I was not audible. All these things that I discussed.
Sir, last two sentences, no, sir.
No, but this SQL developer, PLSQL, SQL plus.
SQL developer, yes, sir, we heard you.
Okay.
And SQL Plus also, like you were saying that you were old school, like you have a,
Okay. Okay.
yeah.
No, it was showing error on my mic, so I was wondering whether you are in a position to hear me or not. Since yesterday I'm having last session, I'm having some problem. Just give me a minute. Testing mic 1 2 3 4. There is some problem. Just give me a minute. So even it doesn't really matter. We should be familiar. We should be comfortable working in either of the case. And on the server side, you'll find people normally working on the command line interface only. And especially when you're working with Linux and other kind of thing, you'll always find people switching over to command line interface. Okay. And as a hardcore developer, you should be familiar. You should be comfortable with the terminals. Correct. You should. You'll find understand the power of terminal also. Okay. Later. So we have an option of you go ahead with SQL developer. I will try and stick to SQL developer because the one reason I'll try and stick to it, because we haven't used in the SQL, correct? And I want you to be familiar with SQL developer as well, SQL developer as well. And SQL plus, Jay has been reminding me every time, sir, वो scripting part बाकी है SQL developer का, SQL plus का. That also I'll take up in this particular course, how we can automate certain things in SQL plus as well. Then something that I wish I could use it, but I'll not be in a position to use it, is the JDeveloper IDE. Now there are two reasons why I will not be in a position to use it. First, it's quite heavy. It is powerful though, but it is quite heavy. And second, it is almost, if you really wanted to make the full use of it, it's a paid one. So there is an option that is available, Oracle JDeveloper ID, but you could just visit the website and see size is huge and complete package. It's not like NetBeans or Eclipse, everything is freely available. It's a paid one. So I'll avoid using a JDeveloper ID. So that option is available. lot of enterprise level where the companies can afford, they will have the J developer ID specifically designed for Oracle. And those who have been with me from early days, we are all familiar with NetBeans. So the base for it is the NetBeans itself. So it has taken the Oracle supports that NetBeans project, isn't it? It is a who is the it takes care, means the funding for NetBeans project comes from Oracle. It's one of the biggest contributor. So they have access to the entire source code. So the heart of this JDeveloper ID is NetBeans, and then they have built on top of it. So think about NetBeans plus plus JDeveloper ID, but then Oracle will charge you. Nothing comes free. So we have multiple options, but we'll go ahead to the free one. SQL Developer is a free option that is available for us. SQL Plus is always there with us. So we'll be working with SQL Developer. And good thing about SQL Developer is it's quite lightweight and it does not require installation like what is happening nowadays with your NetBeans. You just extract or Eclipse always, you unzip it and you start using it. So not much of an impact. You can just carry on a pen drive also and you can start using it. So let's quickly explore all these options which are available. So what is this Oracle SQL Developer? So that's an icon for it. It's a free graphical tool to enhance productivity that simplifies database development tasks. And it's very true. You'll realize how simple it becomes. You are not really bothered about the small commands. If you forget some SQL commands, you can still go ahead further. It will write the basic things for you, and it will definitely improve your productivity because you can focus on the work being done. Now it's not about whether you memorize the command or something like that and whether then you got the answer right. The client is interested in the answer. You make use of the tool or you don't make use of the tool, the code should, the scripts that you write should be perfect and they should run. We should be in a position to test them. We should be in a position to check for their performance, and we should be in a position to ship the product as early as possible. So as this tool really improves our productivity, and you'll find how it really improves our productivity. In addition to that, you can connect to any target Oracle database schema using Oracle database authentication. So we have been doing that, connect, correct? And then username, password. Likewise, over here, we can connect to any schema, sometimes to HR schema, sometimes to OE schema, sometimes to customer order schema. In this course, we'll try and use some other schemas as well. So we can connect to any schema, and just by your authentication username, password, if you can give, you can just connect to any other schema. And we will be using SQL Developer. I'm saying again and again because I'm going to make an attempt to stick to SQL Developer in this particular course. Attempt, no promise, because you'll find me again going back to the command prompt. But I'll try and make an attempt to stick to this SQL Developer for this particular course. SQL Developer is a visual tool for database development. Simplifies the following task. Which are the tasks? Browsing and managing database object. So if I tell you, tell me how many tables are there. The first thing you'll have to do is select star from tabs. Then you can see the list of tables and something like that. Oh, you may say user tables or tabs. Are both of them were same thing. It was just a synonym for that. And then you would like to see the content of it. So then select star from something, something, and so on. Oh, here everything will be done visually. Right button click and view data. You'll get to see the data. If you want to see the schema, just go click on the schema. You'll get to see all the data tables which are there in the schema. You want to delete a table, just right button click and say delete. It will delete the table. No delete, no truncate, nothing of that sort. So you can graphically handle it. It's like browsing and managing database object becomes very easy. And even to execute SQL statements and scripts. So the kind of scripts that we have written till now, create table and everything, we can execute through SQL Plus as well. Not just the code blocks that we are going to write. Even the simple scripts that we have written for inserting some records, or we had created for transaction that we had created, you could still write it, just copy paste over here and run it. Edit and dubbing PLSQL statement. Now that's something very important because now we're going to write code blocks. They're going to be pretty long programs that we're going to write, 15 lines, 50 lines kind of code. So we'd like to edit it, make the changes, not rely upon some editor. Here a built-in editor is also there. You want to debug those things step by step. All those things are possible. And most importantly, you can actually create reports out of it. And something that we have been using for last 30 odd session during SQL, and that is your my favorite, your favorite also, I hope by now, that is SQL Plus. And that's a very powerful tool. We have not yet explored the power of SQL Plus. There is a lot more that we can do. Report generation was one powerful feature that we had seen in SQL Plus. It's a command line interface that enables you to submit SQL statements and PLSQL blocks for execution and receive the results of an application on the command line window. So we can create, we can submit, not create means you'll create a notepad or something. You can execute it. It will execute and it will also generate an output that will be shown onto the console. So, and it's available everywhere, like on Linux, Windows, Mac, everywhere this is available. Same is the case with SQL Developer. We have SQL Developer for almost all operating systems. SQL Plus is shipped with the database. So if you have database, that's already there. That's not the case with SQL Developer. You'll have to separately download it. Install the client on the database server system. By default, you do not. Did you install SQL Plus? No. Moment you installed SQL, the moment you installed Oracle database, the terminal was automatically available. Access using an icon or a command line. We have been accessing by using an icon. You could also create we have been accessing by typing cmd and then SQL Plus. But wherever that SQL Plus is stored, I could have created a shortcut and kept on the desktop, and I could have also accessed it. Either way, you can access it. Okay, and the third, very powerful tool, but we'll not be using it. Okay, I'll not even demonstrate it because it's that heavy. You could want download it and you can experiment with that. That's Oracle JDeveloper ID. And take my word, it's a very powerful tool which is available. It allows you to create, edit, test, debug PLSQL code by using sophisticated GUI. Very, very powerful. It's a part of Oracle Developer Suite and also available as a separate product. So for us, we can download it and we can start using it. It provides color coding syntax in JDeveloper code editor that's sensitive to PLSQL language construction statements. That means if I write if and then else and then all those things will be color coded. So I understand what's the SQL statements, what's the PLSQL statements. Debugging can be done. Very, very powerful tool called as JDeveloper. Now that was about the environment which under which we are gonna work. Okay. Any questions so far? Anybody? Anybody? Any questions? Have you understood what we have discussed so far about the development tools? Quick response. I know you are listening to me. Parag, have you at least understood what you discussed since the time you have joined? You joined in late. Parag, give a feedback whether you understood or not understood. Okay. Now, I was saying like it's heavy. Just have a look at this. So let us visit the website where JDeveloper is there. So you could download JDeveloper by going to Oracle website. JDeveloper 12.1.3, that's the one which is available. And if you look at the sheer size, it's 1.8 GB. You have for Linux, you have for Windows, and you have a generic one. But look at that size. It's pretty huge in size. It's pretty huge in size. Okay. And you could install the older version also. It will require Java 12 at least for you to run. You can have the older version for JDK 7 as well. Okay. So it's quite huge. It's quite huge. 1.8 GB is quite huge. Quite huge. But you can just go ahead, download, and you can start using it. It says download this version 12C for the latest JDeveloper ADF, following direction, guides, other things can be listed. And here we go. And you can go to the documentation page for JDeveloper, how to use it. It's a very powerful tool though. It's a very powerful tool. I will not be using in this particular course. We will not be using this course. JDeveloper ID. What do you say? Is a free integrated development environment that simplifies development. Oh, they made it free. So maybe we'll install it and see. Okay. So you find a lot of resources over here, but 1.2 GB is quite huge. तो चलो free कर दिया है तो we'll also use some part of it. And here the advantage of this would be like even when it comes to creating those ER diagrams and then creating a table out of it, representation, that could also become very, very easy. Now, since they're saying free, let me just keep it for download. Okay. So here we have it for Windows. Oh, now look at that size. The latest edition size is 2.1 GB. The earlier one that we saw was like 1.8 GB. Now that's 2.1 GB. Now that's pretty large in size. Huh? Pretty large in size. Anyway, डाउनलोड के लिए रख देते हैं. You can also download. You'll have to have an Oracle SSO account. So if you really want to download any stuff from Oracle, you'll have to create an SSO account. And once you create this account, it's free. You can just create an account and you can start accessing. A lot of literatures will be available for you from Oracle as well. The documentation specifically, that would be the best thing that you can really get over here. It says disk space 0. क्या बात है? So I'll download it in somewhere else. Okay, so it'll take its own sweet time and download it. Okay, so we'll sometimes work on this as well. So you just have to go to Oracle website and download the ID. Download the ID. Now, since they're saying free, I'll experiment with that. Now, what are the various advantages of going in for PLSQL? I'll just list down them and then I'll discuss each of that point in detail. It says tight integration with SQL, high performance, high productivity, full portability, tight security, access to predefined packages, support for object-oriented programming, and support for web applications and server pages. Okay, I just listed them. Now let me go ahead discussing each of that point in detail. You can make your own guess before I discuss. When I say tight integration with SQL, doesn't require much of an explanation. High performance though will require some kind of explanation. Full portability will require, tight security will require some kind of explanation. But let's quickly go ahead exploring all these advantages of PLSQL. One after another, we'll just go ahead discussing in detail. Now, first, tight integration with SQL. And I know you must have made your guess by now. It has become a standard database language and it is flexible, SQL. Okay, powerful and easy to learn. And we have explored it, we have mastered it, we have learned this, and we know how powerful that SQL as a language is. And especially when it comes to processing the data. So no other thing, and it is de facto standard across the globe. You work with any RDBMS software today, you will have the same SQL language which is there with slight variations here and there, slight. But the standard SQL will now be supported almost by all the databases which are there across the globe. So it is a de facto standard for accessing any commercial standard database which is currently available in the market, SQL. And in this new emerging area of data science and other things, SQL is a must have skill for anybody who want to make career in data science and this new generation where you feel only Python and R will do my work. You're mistaken. SQL is also very, very popular. SQL is also very, very popular. Rather, you need SQL. It's not just about popularity. You need SQL. PLSQL lets you use all the SQL data manipulation, cursor control, transaction control commands, as well as all SQL functions, operators, pseudo columns. So everything that you have learned in SQL, everything is available as it is in PLSQL. Rather, we can make use of all the features, what we have explored in SQL. We can make all of them, we can use all those features in PLSQL. Everyone without any exception. So everything that you learned in SQL can be used as it is in PLSQL. So it's tight integration with SQL. This extensive SQL supports lets you manipulate data, Oracle data flexibly and safely. Why am I saying Oracle data? SQL will work on any database, but PLSQL will work on Oracle only. And Oracle, why are we talking about Oracle so very often? Because it's a market leader. When it comes to database, it's a market leader. So when we write the scripts, through this script, you can manipulate the data much more efficiently than what you could do only with SQL because it provides you the procedural language constructs as well. So you have more control as to how to manipulate. If this data is not available, then what to do? If the insert fails, then what to do? Now that kind of support we do not have in SQL. Either you can insert or you may not insert. If the insert fails, it will give you a statement. So that insert statement has failed. But what to do when it fails? Now you couldn't handle those situations, isn't it? Now here we'll have an opportunity to handle those situations as well. So if it is successful, what to do? If it fails, what to do? If else construct, exceptions, all those things will now be provided. It fully supports SQL data types, reducing the need to convert data passed between your programming, your application, and the database. Now, remember JDBC when you write. In JDBC, you will definitely not have a number type. There will have integer, there will have float and double. So you will have to map your Java data types with the SQL data types. Correct? We had string over there. We don't have anything as string in SQL. Did we use anything as string? We either had a varchar or we had varchar2 or clob and lob and kind of thing. Now, as a Java developer, if you are writing your programming constructs in Java and you're accessing the database, although you may be using JDBC, but there's a mapping of the data types that we need to be aware of. What data type will be mapped to what data type in the Oracle database server and so on. No such thing has to be done over here. Every data type that SQL has a support in PLSQL. Every SQL data type will be available in PLSQL. So now that mapping is no more a problem for us. We can directly process the data as it is. You do not really have to convert into some other type and so on. Nothing of that sort has to be done. So that's the big advantage of going in for PLSQL. You don't have to convert the data as we pass it from the application to the database, because data will be processed in the application, then the data will be sent in the database to be stored or something like that, and then conversion of the types, nothing of that sort. But in Java, even if the data is coming from the database or you're sending the data to the database, you have to be aware about the types that the database supports. Some types the database supports are not supported in Java. Sometimes the Java supports are not supported by the database as it is. So you have to map it. Remember in JDBC we had seen the mapping of the types. Now here you don't have to do that. All those types are understandable by each other. Rather, PLS will understand those things. It integrates control statements and conditional statements with SQL, giving you better control over SQL statements and their execution. Rather, you can control the execution path, how those statements will get executed. Everything can be controlled. So that was about tight integration with SQL. The best part of it was the data type conversions is not required. Second is you have this procedural language constructs through which you can control the flow of your program logic that can be done. So you can do more with your SQL by using PLSQL. Second is high performance. Now that's something that should be of a concern. Now, when I say high performance, we should really have understanding why exactly there is a high performance over here. Let's understand. Without PLSQL, Oracle must process SQL statement one at a time. So you fire one statement that will get executed, you'll have a response, then another statement, then you'll have a response. Means if I want to carry out some kind of operations and the data is residing on the server and through and I have a form in which I have accepting some in fields, I'm accepting some data. Assume that there is a form and every field we are accepting some data. For every data that you're trying to have, it will have to make multiple requests to the server. For every operation that you do, multiple requests to the server will be sent. So program that issues many SQL statements require multiple call to database, resulting in significant network and performance overhead. Now you're working on a client-side application, you're writing your script on the client side, data is on the server side, and you run that particular SQL statement. So every SQL statement you fire, transaction had 10 SQL statements. First statement has been fired. Think about it. A transaction has 10 SQL statement. First SQL statement that you fire that cannot get processed on the server side, client side. You will have to connect to the server. The SQL statement will be sent over the network to the server. It will get processed and you'll get the response. A request response model. You'll send a request to the server. It will process and you'll get the response. Second statement, same thing. Third statement, same thing. Fourth statement, so on. So if I'm firing 10 statements, 10 times I'll have to connect to the database. Understand? If I'm finding 10 statements, 10 times I'll have to connect to the database. So 10 SQL statements, 10 times connect to the database. That is a significant overhead on the network. And today, network is a bottleneck for us. Your server may be very fast, your client machine may be very fast. How can you control the bandwidth, the network that is there? And this constant movement of data to and from the network will create performance bottlenecks for you. Now, how will PLSQL change this particular behavior? It will totally change this behavior. What can happen in PLSQL? The entire block of statement can be sent to the Oracle at one time. That means if I had the 10 statements, SQL statements, I'll not be making 10 requests to the server. Rather, the entire block of 10 requests will be sent as one block to the server. And PLSQL can reside on the client side and the server side. Server can also understand the PLSQL block. So I'll send the entire PLSQL block to the server. So only one time connecting to the server. It's not like multiple times, every time I'll connect and disconnect from the server. Nothing of that sort. So that will decrease the network overhead. This will drastically reduce the network traffic between the database and the application, because through the application you're making the request, processing is done on the server side. The entire SQL block can be set on one go. At one go, you can send the entire, it could be of hundreds of statements. It will go as one block, and SQL server also understands the PLSQL blocks. So it will receive it as one block, process all the statements and give you the final result. Isn't it powerful? So that will give a huge impact performance benefit. Huh? If an application of SQL is application SQL intensive, there are too many SQL statements, not just the processing constructs. There are too many SQL statements. You can use PLSQL blocks to group SQL statements before sending them to the Oracle database server for execution. So if there are too many SQL statements, put them into an SQL block. Send one block. Don't send every SQL statement separately. Club them together into an SQL block. SQL block, as one request will go to the server. One time you connect to the server, all those statements will go to the server. If it's a SQL sensitive application, there are too many SQL statements that are there. Bundle them in a block, send the block to the server, let the server process the entire block at one go. Let the server. PLSQL stored procedures are compiled once and stored in executable form, so procedure calls are efficient. This is the most powerful feature. Now what I'll do is, if there is some operation that I have to constantly go ahead performing, correct? So what I'm doing is, I'm constantly making requests to the server. I'm sending those SQL statements to the server, and the server is receiving that entire SQL block, which contains multiple SQL statements, and it is processing. Don't do that. You can have a more efficient behavior over here. What will I do? SQL code blocks are database objects. Now, if there are database objects like tables, tables are stored in databases. Likewise, I can store the SQL code blocks on the database itself. So through your application, now you will not send the SQL block to the server. Instead, the SQL block, like a procedure or function that is already pre-written, will be stored on the database itself. Remember in Java, we had seen called stored procedures. So that entire PLSQL code block is stored on the server where your SQL engine resides, SQL statement executor resides, your PLSQL engine resides on the server itself, where the data processing has to happen. And in your Java application or in your PLSQL application, what will you do? You will only call that SQL code block. That means will not even transfer the SQL code block from the client to the server. Will not even do that. That means from my application, I'll not even send that one entire group of 10 statements bundled inside an SQL block, PLSQL block. There are different types of blocks. So I'm using the term only block. And later I'll tell you what are the different types of blocks. I'll not even send that entire block of one block of PLSQL statements to the server to increase the network traffic. Although it's better than sending 10 SQL statements, 10 times connection, 10 times disconnection. No, one option was bundle them into an SQL block and send one block. But the block can be pretty large in size, isn't it? Instead, what will I do is, if I know that statements are to be repeatedly executed, I'll store that SQL block on the server itself in form of a stored procedure or in form of a function. I'll store it on the database itself. And through my application, I'll only send one call to that procedure. So that procedure is residing on the server. From my application you can write in Java, Python, C, C++, PLSQL as well. So I have written an application in PLSQL. Now that we are learning PLSQL, we will not talk about other languages. Now we have written application in PLSQL. I'll make a request to the server, but in my request, I'm neither going to send the SQL statements, neither I'm going to send one PLSQL block. That PLSQL block is already residing on the server. I have an opportunity to store it on the server, create table. Likewise, I can create that SQL statement block and keep it on the server. It's just like making a function call. I'll only call that PLSQL block from my client side. So only the call will go transfer across the network. No statements will go. Only the call will be transferring across the network. The entire processing of that block, the block is already there on the server. So the time that is taken to move that block is also reduced. It's there on the database server. I'll only identify which block I would like to execute. So the call will be made to the server. The block is already there on the server. It will execute on the server side itself and give me the final response. That can come on a web, that can, it can be like interface, can be anything, but that can come to my application can be a full-fledged Java application, PLSQL application, or it could be a web application, means web interface that I have, because we can also create web pages through PLSQL. So it could be anything. Data will come back to you, but no sending SQL statements over the network, no sending SQL block over the network. Blocks are already stored on the database. That's the powerful feature that we have. You can store Java code on the server and Oracle server. Here, PLSQL code blocks can be stored on the server. So that will improve the performance significantly. It will improve the performance significantly. That was about high performance. So understand why there is a need for us to know this, why this is a skill which is so very important today in the market, because it gives you tremendous improvement in performance. And next point is very easy: modularized program development. Okay, And we know modularity always reduces complexity, isn't it? If you can break a big task into several small tasks, since early days we know breaking a bigger program into several small program is always going to make our job easy. Now I have Karan with me, I have Mayuresh with me, I have Pradnya with me, and I alone end up writing the entire code block. They are still going to watch. Instead, if I divide that big block into small blocks, I can give one task to Deepak, one task to Karan, one task to Pradnya, one task to Prathamesh, and say, "आप ये code block लिखिएगा," and I'll only integrate those code blocks. Decomposition, if you remember, the in programming, the most powerful feature is decomposition. If you have an idea, if you see repeated patterns, decompose those things into separate parts and build those parts separately, and then combine them together to create a large application. That modularity feature is also made available over here. The basic unit of PLSQL program is a block. And today we'll have a glimpse about what are the various types of blocks that we can come across. Blocks can be in a sequence or they can be nested in other blocks. So we can have a block within a block or block after a block. That's also can be done. In PLSQL, modularization is implemented using procedures, functions, and packages. Now these terms are not new to you. Some other language you have, or almost every language you have used the term function. In most of the languages, you also used packages or header files. So you have a pretty good idea about what packages would be doing for us. And we have used exactly the same term in Java and in Python. We have used the term packages only. But we have packages. And by now you must have guessed, related things are clubbed together inside a package. The only new thing that we see is a procedure. In logic, we discussed procedure. We said it's a sub-program. Yeah, it is a sub-program. But how is it different than function? We'll see today. But then all of them are modules. We are dividing a bigger thing into several small parts and also clubbing them together based on their relevance into related package. So similar kind of things will be clubbed into a package. Modularization, a modularized program development has following advantage. You can group logical data statements within a block. Logical data statements within one single block. You can nest block inside larger block to build a powerful program. So a function calling another function. So that's what you can do. It gives you flexibility as well. If you are designing complex application, PLSQL allows you to break down application to smaller, manageable, and logically related modules. When I use the word modules, that means I'll create several packages. I'll bundle them. Say functions and procedures required to IO, like we in header in C++ we had stdio. In Java we had IO package, isn't it? So likewise over here you can create your own package wherein input output feature will be provided. Don't have to do that. There is already ready-made support available for it. But just to give you an idea, so you can club them into an IO package. So next time I can say from this IO package I'm going to use this. So and development also improves, na speed improves, because a developer who is developing that particular module does not need to know the entire picture. He's going to focus only on the small task that has been assigned to him. Development also speeds up. You can easily maintain and debug the code. If you have small blocks of code, they're always easy to maintain, they're always easy to debug. Rather than having one code of 1,000 lines, I'll have 10 codes of 100 lines. So 100 line code is quite maintainable than having that 1,000 lines code which is there. Now, let's talk about this PLSQL block structure. Okay, we have been talking about this block so very often, correct? The benefits of using modular programming constructs are easy maintenance, improved programming security and integrity, improved performance. Security and integrity, I can restrict access to some blocks and I can provide access to some block. That can also be done. Huh? Improved performance, we have discussed in detail. Improved code clarity, isn't it? One, it's like smallest unit of code. So if you look at it, I immediately understand what's the purpose of this particular code. It will not be like everything दुनिया भर की सारी चीजें एक ही जगह की है. No, all related things will be clubbed inside a package. But every function, every procedure will have a unit task. Has a purpose. And so looking at it, you'll understand what is that it is trying to achieve. Uska objective kya hai? What is that we're trying to achieve? You will get to understand just by looking at that particular code. So code clarity. Focused rahega. Single task they will try and achieve. Okay. Uh, and then there are a lot of integration tools also that it provides us. PLSQL engine is integrated with Oracle tools such as Oracle Forms and Oracle Reports. Now these forms and reports are so very important for us, correct? You would like to, because all applications at the end of the day they generate reports. And for you to generate input, you have to get some data from the client side, correct? So you have support for some additional tools which are available in Oracle with for us, like Oracle Forms and Oracle Reports, which is out of scope for us. But then this engine is integrated with these tools, forms and reports. So we can use this PLSQL engine along with these forms and reports very, very easily, seamless integration. When you use these tools, the locally available PLSQL processes the procedural statements. Only the SQL statements are passed to the database. Think about it. I create a simple form, not an HTML form this time around, not a GUI that I created through Java or through Python. I have used Oracle forms precisely, end-to-end Oracle products. I use Oracle form. And there is some validation which has to be done for some field. The code is there on the server. So in that case, some procedural part of it, that processing can happen on the client side itself, in the Oracle form itself. And where there is an SQL statement, it'll again connect to the database, do that validation and come back to you. So some part of the processing can happen on the client side and some part of the processing can happen on the server side. That is something that we can achieve by using these Oracle forms. Not necessarily that every time you have to connect to the server. Not necessarily that every time you have to connect to the server, because you're not manipulating the data that is stored in the database. You want to do simple validation checking whether the suppose email ID may it shouldn't start with a number. Validation you want to do. So you don't have to go and cross check in the database. Na? So that code could have been checked by the PLSQL block by using if else construct and loops on the in the form itself, in the application client side itself. So no need to connect to the server. When the data is right, then I have to insert into the database. For that, I'll send it to the server. Correct. So some processing can happen on the client side without connecting to the database. And once the data is authenticated, then I can send it to the authenticated means when validated. I will not say authenticated because for authentication, we need to connect to the server. Once the data validation we have done, and if you feel the data is right, then I can connect to the server, send the data to the server request and so on. Another thing that it provides us is portability. I gave a wrong heading to the slide. Let me just quickly change the one of the headings. Here we go. Now we are talking about portability, and portability. So very common term. We have been listening to it right from Java days and I think portable. Portable is like it should run anywhere, correct? So the PLSQL code block runs. Wherever there is Oracle running, you don't have to worry. You don't even have to ask your client, क्या आपके पास Oracle on Linux है, Oracle on Mac है, या Oracle on Windows है? If it has Oracle server running, be rest assured your PLSQL will also run over there without any problem. Portable. PLSQL programs can run anywhere an Oracle server runs. So wherever Oracle server is running, without any problem, your PLSQL code blocks will also run, irrespective of the operating system and the platform. Whether you are working on Linux, Windows, Mac, whether you are an HP server, whether it's a Sun server, or whether it's a Intel machine, don't have to ask. As long as your Oracle server is running on that particular machine, your PLSQL programs will also work. You don't need to customize them to each new environment. So just because the operating system has changed, just because the hardware has changed, you again have to customize it and make it run over there. Nothing of that sort has to be done. It will seamlessly run. You can write portable program packages, and create libraries that can be used in different environments. You will create a package, module, library, header file, you call it anything, and you can reuse them across all platforms. Just ship it and client will be in position to, the developer will be in position to use it. Don't have to talk about which operating system it is. Wherever Oracle is running, there this particular things will run. No setup to be done, no integration to be done, nothing. Wherever Oracle server runs, all these blocks that we write, the modules that we create in PLSQL, they are bound to work. No setup required, nothing required. And then in the new generation languages, what they provide is this very powerful feature of exception handling, error handling, exception handling. Okay, we saw this only in the next generation language like C++ and Java and Python, we have seen it. And similar support with almost the same syntax is also available in PLSQL. It allows you to handle exceptions efficiently. You can define separate code blocks for dealing with exception handlers, what to do when that error occurs. You can create your own handlers. PLSQL share the same data type system as SQL with some extension and use the same expression syntax. So whatever syntax that you learn in SQL, it's a continuity. There is nothing new that you have to learn. There is nothing new that. And then we are talking about high productivity and full portability. Oh, we talked about portability right now, isn't it? When I say portability means wherever Oracle server runs, there is where my PLSQL block is going to run. It lets you write compact code for manipulating data. A query can transform, update data in the database, and we learned how The procedural part will be managed by the PLSQL engine. And inside it, wherever you are making some manipulation of the data, that will be sent to the SQL statement, that will send to the SQL statement executor. Within the SQL statement executor, if it again refers to some PLSQL block, that will again come back to the PLSQL engine. And that's how they will manage the entire working. It saves times on design and debugging by offering a full range of software engineering features such as exception handling, encapsulation, data hiding, object-oriented data types. Whatever you have learned in all these new generation languages, everything is available there. Even construction of objects and everything is available. Then talking about tight security and access to predefined packages. Procedures move application code from client to the server, where you can protect it from tampering, hide the internal details, and restrict who can access. So there is a function, there is a package, and that you have written. It should be accessible to user A and should not be accessible to user B. Remember, when we create a table, didn't we grant access to the user for some table and revoke the access to some table? So likewise, you can provide access to some kind of stored procedures, code blocks to some user, and some users will not have permission to access some code blocks. That can be done. So you have a code which is there on the server, not necessarily that every user who logs onto the server will have an access to that code block. We can control who can run which code. We can control which user has a permission to call which feature. It's like you're somebody's a clerk and somebody's a manager. Both of them using the same application, but based on your role, you will be now having permission to access some part of the application, and some part you will not be in a position to access. So tight security. Oracle provides product specific package from that defines API that you can call from PLSQL perform that may perform many useful tasks. Now, you don't have to start from scratch. You don't have to write everything on your own. Like in Python, you had a lot of packages. In Java also, we had a lot of packages. In C, C++, with a lot of header files. What were those? They were pre-written code blocks, which we can directly use. You say hash include stdio, start using printf scanf. You say in Python, you say import OS, and then you start using all the features which are provided that OS module. In Java, you say import java.io, and then you use all the input output things. Likewise, there are a lot of predefined packages which are supplied to us, shipped to us with PLSQL, and for input output, for operating system tasks, for connecting to the internet, predefined packages are there. Each of these package will provide you code blocks like functions and procedures and everything. Just start using it to fulfill your work requirement. Don't have to write from scratch. So most of the commonly occurring requirements have previously been implemented and supplied to us in form of those packages which are available. You can just refer to them and start using it. It supports object-oriented programming constructs. Object types are ideal for object-oriented modeling tools, which can be used to reduce the cost and the time required for building complex application. So object-oriented features like encapsulation, data hiding, all things are supported here. It also has support for web applications, and even the server pages can be server pages. Normally, when you talk about server pages, what comes to our mind is the JSP, Java server pages, or ASP. That's what comes to your mind. And we have over here PSP as well. Okay, that's PLSQL server pages. So you can also create web application, although it's not so very popular, because from the Oracle side itself, we have this very powerful thing from the house of Java. We have JSP, which is available, Java server pages, which are foundation for most of the server this constructs which are web application development. But then we have support for web applications and server pages through PLSQL in form of PSP, like JSP, ASP. Now we have PSP also, which is available. So think about it. You can develop end-to-end application in PLSQL. So you don't even have to know Java and Python to create an application. The complete application can be created through PLSQL if you want to. Okay, so that was a brief. Any questions so far? Anybody? Any questions? Anything that comes to your mind? Quick, any questions if you have, please ask before I go ahead with discussing. Have you understood what you have discussed so far? Click on yes or no. Parag, explore the interface on your mobile phone. If you hold your phone horizontally, you'll find those buttons where you can give feedback. Yes, no, did not like it, whatever it is. हॉरिजॉन्टली पकड़ो फोन, सो यू विल हैव द इंटरफेस, यहाँ बटन दिखाई देंगे. आदित्य, okay, let's continue with our discussion. If there are any friends of yours who are also interested in PLSQL, who are already finished with SQL, they know SQL, please invite them for the session. Let them attend tomorrow's session. Let them see how the things are around. That would be a great help for us. So I request you to inform your friends about these PLSQL sessions that have started. And those friends about your friends who have not come down today for the session, who are already a part of this course, remind them कि miss ना करें, because introduction also helps you. Because there are some aspects about that I talked about introduction, वो अपने कोर्स में नहीं रहेगा, but आपको वो scope तो पता चला. Now one thing that was very important to hear was, which I will not be taking this course, how to develop web pages. So web pages can be developed through an PLSQL. ये अंडरस्टैंडिंग है, एंड दैट विल गो लॉन्ग वे. कल जाके आपको डिसीजन लेना है प्रोडक्ट डेवलपमेंट का, तो ये प्रोडक्ट आपको क्या क्या सपोर्ट दे सकता है मालूम तो होना चाहिए. एंटायर ऑब्जेक्ट ओरिएंटेड लैंग्वेज फीचर्स आर अवेलेबल, although we'll be touching on few aspects, but all object and features available. So don't miss even the introductory session. Don't be under impression, oh वो जो advanced के topic शुरू हो जाएंगे then I'll join. Don't do that, and be regular. Okay, so with that we stop for today. Thank you all once again for attending the session. See you tomorrow at 7 a.m. and we continue with our discussion on introduction to PLSQL. Bye bye. Good day. Take care. Love you all. And one more reminder, I uploaded yesterday a lot of, I sent you a mail as well. You must have received it. I have uploaded yesterday on our e-learning portal several notes, which will help you to revise whatever we have discussed in the sessions. Notes, and that notes goes ahead with example scripts. So it's more like the session log that I provide you. So session log with explanation. So regarding external table, regarding flashback, and one more thing, remember our flashback, somewhere we couldn't execute some operations. Do you remember that time? And you remember some aspect of our flashback we could not run. We could run it only through SCN number.
Save points. Save points.
Remember that?
Yes, sir.
Okay. Now yesterday, so advantage of going through the documentation. Yesterday, while I was going through the documentation, I realized they have for that save points and everything to settle down, and so that we can revert back to that. We couldn't revert back. That was the problem. Yes or no?
Yes, sir.
Okay. It requires minimum 5 minutes time duration for that thing to happen. So after 5 minutes, you can do that. So go through the notes. You will have solution for the problem that we had faced. And we are trying to execute it and immediately run it, correct? We are trying to do it within 1 minute or 2 minutes. We are trying to do it. There's a 5 minute gap that is required. So in between, whatever happens between 5 minutes, that will not be maintained. 5 minutes gap is default, and that can be changed. So do go through the notes. You will have the small things here and there. I was trying to figure out, ऐसा क्या गलत लिखा मैंने? What I have written was 100% right. Only गलत चीज जो हमने की थी, we did not wait to roll back, to go back for 5 minutes. So after 5 minutes, you would have done that. You could have seen that particular behavior. So go to the notes. I have a detail. I was actually yesterday I had some time, so I went to the documentation, figuring out what was going wrong, and I figured out it was only about the time. It was only about the time. We had to wait for 5 minutes. So go through the notes. They're small notes, 5-10 pages here and there with examples. So don't go by the number of pages, because the examples are also there in that. Go through it. It will help you a long way. There is one additional article by one Oracle architect that I have posted. It's a fantastic article that I came across. Read that article as well. It's not my article. It's somebody else's article. I have Chris. He's an Oracle architect. Fantastic article. I have uploaded that article as well. Go through those additional contents. Thank you all. Bye-bye. Good day.